the topic here is power and connectivity challenges. So I will start by presenting the agenda first. This is fairly typical, fairly technical question, but it's an important one because this is at the heart of problems that are facing meter manufacturers, but also in the full interest of water utilities. Here we're speaking of concerns like rising operational costs, concerns like water conservation pressures, and connectivity challenges in remote areas. And all these questions, topics, require strategies that extend battery life, that reduce total cost of ownership, and ensure a future-proof smart water infrastructure. So important topics that we'd like to address. So you have the agenda. I will start by saying just a few words about Itron and then dive into the topic at stake. Itron at a glance, you have some data on screen which should be useful to locate us. We are a leader in the management of energy, water, and IoT. You have here on screen the number of communicating endpoints that we manage. Just to say that we do, of course, have the experience of these technological topics of balancing data and power, with over 285 million endpoints. That includes about 40 million smart water devices, give or take, and including smart communication modules and smart water devices. So enough about us. Some trends, because it's always good to start with placing the discussion in the frame of the market and utility concerns. A number of things to go briefly over: aging infrastructure, operational constraints. You have underground assets as part of the water world that are very costly to maintain. You have leaks. We've discussed that already today. Replacement is becoming critical, and utilities are seeking to optimize their processes to reduce budget and under resource constraint. One thing to consider with a huge impact on smart metering. The next one, of course, is climate change. So you have conservation plans now for utilities. You have key performance indicators, sometimes closely monitored by regulators. And you need to take into account these conservation plans with digital utility IoT strategies that are now put in place at many utilities around the world. You have forecasting, demand management, so that involves consumers involvement around water conservation, and forecasting, which all contribute to customer satisfaction. And last but not least, again, a topic that we've discussed today, open, standardized, low total cost of ownership technologies, and LP1 fits in very well. We'll talk about that later, with low cost per endpoint, reliable, secure communications, enabling data quality, granularity, integrity, completeness, the works, everything that utility need to actually implement the strategies needed to save water and to manage an aging infrastructure. For a second, a bit of history. The need for data has been exploding, increasing tremendously over time. Building this graph that you see, it's very simple stuff, moving from manual read, so one read per year, more or less. Okay, it's a bit simplified. More recently to walk by, drive by, to AMR technologies, so 1 to 4 reads per year, okay, give or take. And even more recently to AMI, and again, this is a process that many utilities are undertaking now as we speak. Many are still doing manual reads, a mix of manual and AMR, or everything going up to AMI, which is 1 to 4 reads per day. You can see on the graph, and it's going upwards very fast. And now the current trend is moving to real-time, near real-time. Okay, that could be a discussion for later, perhaps. Especially in case of major events on the water network, freezing water, pipe burst, backflow, things like that might impact the safety of consumers. The challenge here with the explosion of connectivity is battery. I'm not other experts that have been speaking about that, but still, it's very important. It's key for smart meter manufacturer to speak about power innovation, increasing power needs for smart water devices. With the increase in data transmission demands, we saw that, and new, more power-hungry protocols. We'll speak about the protocols, but they also require power to process. More efficient radio designs to save also power consumption. Sleep modes, we've talked about that also today, that are extremely useful to manage that need to have 15 years of data, which is now the standard by which everybody is measured. And that protocol level optimization are everywhere. Mentioning here NB-IoT and LoRaWAN, we could include, of course, many other protocols here, but you have things like power saving mode in NB-IoT. You have extended discontinuous reception, enabling to reach the appropriate level of lifetime. You have adaptive data rate for LoRaWAN, which is extremely useful to make sure we get to that endpoint where we reach the necessary lifetime. And we have also the next generation cellular, which is coming with 20% more efficient than the previous generation. So this is an ever-going race, which we're all, of course, participating into. Other strategies like avoiding direct long-range transmission, thinking of the LoRaWAN relay, for instance, which is also very interesting. Many innovations that are fueling the design of smart water and enabling to match the race for data. I won't spend too much time on that. I won't enter the LoRaWAN versus NB-IoT debate. You have scoring here that is Itron's own, and we can argue later if you'd like. There are pros and cons. I'll go fast for the sake of time, but there are very different protocols that all have their specificity, good points, and things that we can compare one to another. There are trade-offs, and there is the future because it's always evolving. Okay, we've been discussing a lot about things like the list is not extensive, of course, 5G RedCap NR for IoT and e-RedCap, which could be the next great things about connectivity options for smart water metering that we need to take into account for the future. But the main message here is that there is no single silver bullet, of course. You don't have the great protocol that will solve everything. And the strat to fit all use cases, you have urban deployments, rural deployments, you need data volumes, you have pits full of water, you have many different things in the field that we need to take into account. Latency questions. Combining technologies is always, we found at Itron, the best option. Keeping our minds open and having a strategy in the design of our solution to integrate these different technologies and have always one step in advance. So using standard-based protocol, I'm not the first one to say that, is of course a good solution. Build a platform approach, think ahead in terms of design to be able to integrate these technologies under one single management system to make things easier for utilities and enable future proofing. So how about integrating 5G RedCap and R? We need to think about that now. These conversations are happening as we speak. And I don't know if it's the most important, but this is really critical backup. Always have a backup and a backup of a backup and a backup of the backup of the backup and so on. Because that's what matters in the field, and that's what we feel every day as part of our everyday lives as a meter manufacturer. So in terms of takeaways, basically more data means more power, smarter connectivity. We've discussed that throughout the day. We've seen huge improvements in radio infrastructure, in battery performances, that at the end of the day is not only about technological challenges, but enabling for utilities visibility on the water network. And that's all that matters. And the choice, we can oversimplify it by presenting the triangle with cost range, which are often discussed today. Resiliency is also critical. Making sure that whatever happens, you get the data for billings, Okay, meter is always a cash register, and to enable water savings, to enable managing aging infrastructure. So that's it for me. Thank you very much.